Hello and welcome to the Foundation sort of secondary school live stream for today. I've tried to set it up and hopefully it'll look a little bit more professional. I don't know whether it will, but we're going to try and make it look that way. I've got a lesson plan all on rough estimations and hopefully by the end of this lesson we'll have covered an awful lot of material and you'll have a better understanding. I'm hoping I remembered to unmute. I did when we were ready to begin. Okay, so what we're planning for today is going to be much easier if my screen doesn't freeze. That would be awkward, wouldn't it? Oh, bottoms. This is not what I was hoping would happen. So, I need to quickly unfreeze everything and start again. I do apologise about this. I will quickly put myself on just me and I'll try quickly and frantically to get it working again. How awkward was that? Right. There's a chance I can get this working now. Oh, well, this is the first time we've had anything like this happen. Let's try one more time. Apologies for all the delay. There's only so much you can do. The best laid plans of mice and men, as they say. Forgive me. We're nearly there. And hopefully, I'm so sorry for the delay. Just doesn't want to work. Right, there is a way around this, but I'm going to have to very quickly do this. Apologies for that. Okay, what a terrible start. This is all the work for year 7 to 11. Maybe some year 5s and 6s will be here with us. Hopefully you'll keep up. What we're going to learn today is we're going to learn a little bit about estimating. We're going to learn a little bit about rounding. We're going to learn a little bit about why we estimate things and how we can use to do things visually. Okay, so I'd like you to look at this. In this selection of things, you have not got time to count them because I'm going to go in 3, 2, 1. I'm going to make them disappear. I'm going to bring them back again in a second. But when you see them next time, you are going to have to decide a number of how many you think there are. How many of those that you possibly think there are. There you go. So, you have 1, 2, 3 seconds. Write down a number. Write down a number somewhere of how many things you think there were there. It's quite interesting, in fact. I would hope if I can get a few numbers from the chat, that would be really helpful just to know how many numbers people think there are there. So I would like you to write down a number in the chat if you're watching it, and you can tell me how many. We've got a guess of 40, got a guess of 45. Any more people wanting to put a chat down thing? This is going to help me with 53. Okay, 31, 43, fantastic. That's enough guesses, brilliant. Thank you for those people doing that. If I add all those together, 40 plus 45. Now this is called the wisdom of crowds. The wisdom of crowds suggests if you get enough people, and I find the average of those numbers, I've got an average of 42.4. Well, I can tell you there were actually 48 objects there. 42.4 isn't far off, given it rounds to 42. Given that there's 48 there, that's only 6 out. And that's called the wisdom of crowds. If you get lots of people to make an estimation and add them all together, if we did that with 100 people, it's quite likely that the average of adding all their answers together and dividing it by 100, you'd get something close to 48. But we're talking about visually estimating. How did people go about it? If I was estimating these, I'd look at them and go, well, there's approximately maybe 10 along the top and 6 down the side. I'd probably go 10 times 6, 9 times 6. Let's go 9 times 6 is 54. That's not a bad estimation. 48 and 54, that's 6 out. That's what we were all out. Now, the second one is this shape. I'm going to tell you that that little square has a square size of 1. What do you estimate the area of the big one is? You need to estimate what you think the size of the big shape is and say what you think it is. Okay? So, how many you think there are? How many of those little squares fit in that shape? I'm going to make it go away again. Like before, I want to see those numbers in the chat. I want you to write down what you think the total estimate of that area is. How many of those you think go in there? We've got a 20 from Willow. Anyone else want to join in? Because I'm going to take the first 5 numbers. That's 25, 25, 30, 20, 35. Brilliant. They're the first few I've seen. I'm going to add those together just like we were talking about before with the wisdom of crowds. 30 plus 20 plus 35 divide by 6. Your answer you've given me is 25.8 or 26. That's approximately equal to. I can tell you the actual area is 28. It was 7 by 4. Let's have a look again. Roughly speaking, we've got down the sides, I think if I point this way, it should work. There's roughly 4 down in height and 7 across the top. 4 7s are 28. So it's actually 28. But 26 is a very, very close estimate. And this is what visual estimation is all about. Now, another type of visual estimation we can use is as follows. What we do is you take your finger, if you're looking at something in the distance. Now, out of my window, I can see a building quite a long way away. If I put my finger out here and line it up with the window, and then I close my eyes, it jumps a whole house to the right. That is a whole house. If I know roughly how big wide a house is, and we're going to go with 10 metres just to make it interesting, what you do is whatever you think the width of the object is, if you times it by 10, that gives you a visual estimation of how far away it is. So roughly speaking, if that's got a width of 10 metres, that house, and when I close my eye and change it right round, I probably look very odd doing left and right eyes. Then when I look at my finger to how far it moves, it jumps about 10 metres. That means it's about 100 metres away. And that's probably about right. I wouldn't like to run it because it's got trees and hedges and things in the way, and we're not allowed outside anyway. I haven't been for my run yet, but I'm looking forward to that this afternoon in the sunshine. Now, moving on from visual estimation, I'd like to talk about rounding. Now, a lot of you will have done rounding to decimal places, and some of you will have looked at rounding to significant figures. Well, what does it mean? Rounding to significant figures is not like decimals, where you go to the decimal point and you start there, and this is what I was going to do on my board. If I'm rounding to a decimal point, I've got 7.3259. So I've got my number. I'm hoping you can all see that in the corner of your screen. I'm just going to see if it's possible to make myself a bit larger. I can do that just here. It's a bit weird, but you have to see me being a bit bigger for a second. Okay. So we've got this number here. To round this to two decimal places, I count 1, 2, and I put a line after the 2. Then, because the next numbers are 5, that's going to make it into 7.33 to 2 decimal places. But what we're looking at now is significant figures. Significant figures counts, instead of starting at the decimal place, to have 2 significant figures, we're going to start at the front of the number with one exception. It's the front of the number, ignoring any zeros at the front. There aren't any this one, but I'll show you one afterwards if there are zeros. Starting at the front of the number, we've got 1, 2, so we'll put a line there, and that will give us 7.3, because 2 is a rounding down number. So that would be 7.3 is it rounded to 2 significant figures. Now I did say I'd do an example to what if it starts with a 0, because we have to be able to do 2 significant figures also from 0. Well, if it was 0.08472, then I ignore all the zeros before the 8. So I'm going to ignore him and ignore him. Going from the front of the number, that's number 1 and that's number 2. So that's where I'm going to put my line. I'm going to put my line after the 4. 7 is a rounding up number because it's 5, 6, 7, 8 and 9 are rounding up numbers. So it's going to go to 0.85. And there we have 0.85. What I'd like you to do is pause the video and have a go at the questions that are there. I will be showing answers shortly, so there's no point you doing that. Or wait until after the video and have a go at them. Obviously, the answers I'm going to show in a second will spoil that a little bit, but I'll only put the answers up very briefly. That allows you to pause the video when the answers are on, but without being able to see all the answers and just copy them down or anything. So here we are. For those people who want to do these later, here's some answers: 1 significant figure and 2 significant figures. Any questions you have, then please do always send me a message in the Facebook group or send me an email and I'll happily go through, or in the comments below the video. I always try and respond to the comments, and if you have any questions on how it worked or how did I get that answer, I'm more than happy to explain. It might be that you spot a mistake. Sometimes I make mistakes. We all do. And if you spot a mistake, then that's fantastic. Just point that out and I'll happily acknowledge my mistake and learn from it. That's the key thing. Now, we've been asked now, moving on to estimating, we've been asked now to estimate the answer to 6.32 times 9.5. 6.32 times 9.5. What that means is we want to get the answer, but if we used a calculator, we would do that times that and we get the answer 60.04. But we're not using a calculator. We have been asked to estimate. That's not guess, but it kind of is similar. We're using 6.32, and in estimating we always use one significant figure. So we go from the front of 6.32 and it just becomes 6. We also do that with the 9.5 and we just get 10 because the 5 rounds the 9 up to a 10. We've now got 6 and 10. We can now multiply them together, and I think you'll agree those round together, and that's my approximately equal symbol. Wavy equals is how we do. It's not exactly equal to, but it's about the same as, and that's the proper way of writing them. And we get 60. And I think you'll agree, 60 and 60.04 are very, very, very close. So therefore you can see this is a method we can use to estimate answers quite accurately. Now, one thing I might ask you is, how do we know whether it's an underestimate or overestimate? Well, 9.5 went up to 10 and 6.3 went down. So actually, we wouldn't know whether that's an underestimate or overestimate until we work it out. But sometimes we'll have a question where the one number goes up and another number goes up. If we've rounded both numbers up, we know we've got an overestimate. If one number has gone down and the other number's gone down, we must have an underestimate. So that is a good way of working out whether someone's likely to be right or not. The next one we're looking at, again, feel free to pause the video, attempt it yourself, and then unpause to see how you got on. Sally bought 18 packets of crisps at 32p each. So to estimate how much she spent, here we go, she's back again. Sally sometimes runs off. She gets a bit scared of being on the camera, doing the live stream. It's not her fault, so I hope we can be understanding towards Sally. She bought 18 packets of crisps at 32p each. If we had a calculator, we would do 18 times 0.32, but to estimate, we round 18 to 20 and 32 to 30, and so now we get 600 pence, or £6. This is quite close to the 5.76 you need, and this is why it's useful. Practically, if we were going around the supermarket and I wanted to make sure that I wasn't overspending, and I had, say, a £20 note, I know that I've got plenty of money for this £5.76. £6 is a perfectly a legitimate estimate for that amount of money. So that is why it's reasonable. Okay, the next one we're going to look at. We have here some questions to estimate. Now, unfortunately, the answers appear to be on the screen at the same time. As I say, I'm still having some teething issues. This wasn't supposed to happen, but I'm having to make do with a system that I wasn't planning when we first started. Doesn't matter though, because what I want to know is, can you make these questions into these answers? I don't mind you seeing the answers. I want you to be able to work out why that question gives that answer. So why is 2.2 times 2.6 all over 2.6 2? Well, to do this, we do the top line of the fraction first. 2.2 becomes 2, 2.6 becomes 3, and 2.6 on the bottom also becomes 3. Remember, we always use one significant figure for these questions, so I've reduced this into 2 times 3 over 3. I then do 2 times 3, which is 6, and divide by 3. That gives me 2. Therefore, I've got 6 divided by 3 is 2. I've also got 4 or 5 more questions that you can pause the video or go back to at any time and see, can you make those numbers get that right answer? Have a go now. Or later. But one of the main reasons for estimating is for real life examples. We have some information. This is an Olympic-sized swimming pool. That swimming pool is something that we want to know how much water we need in it. And we've got some information. The average height of an adult is 1.8 metres. The length is about 27 adults. I don't know which adults they used to lie down in the pool to get this to happen. I assume they waited till it was closed and then got 27 adults to lie down head to head. Obviously, it was before the social distancing took place. The width is about 14 adults. Again, I don't know which adults. I wasn't involved in the adults. Before people get message saying, oh, was Mr. Harris involved in the measuring of this? It wasn't me, because I'm 1.9 metres, so I would have broken the average. But the average of so it was 14 adults. And the pool is about 1 adult deep. I know in most pools at the deep end still, I can stand up, the water goes to about there. So it's about 1 adult deep. So what do we do? Well, in order to estimate this, we need to use some facts. We want to use estimation to work out how much water is in this pool. And the facts we're going to use are that 1 metre cubed is equal to 1,000 litres. So therefore, if we know that 1 metre cubed is equal to 1,000 litres, let's work out how many metres cubed. We need a fact. The volume is the length times the width times the depth. And we have some facts about the length and the width and the depth in there. But we don't really want to use 27 and 14, so we use our estimating. We use our one significant figure. 27 becomes 30. Let's write it down. 27 is going to become 30, and 14 is going to become 10, and 1 is going to stay as 1, so therefore the volume is going to be 30 times 10 times 1 equals 300. That's 300 metres cubed. I've written it all down for you there. Hopefully you can see my writing properly. And this is roughly what I've just done there. We've got 27 times 1.8 because we need to have that many adults. So another way of doing it, this is the number of adults. What I forgot to do here was multiply it by the 2 for each adult, which is where on the screen you can see it's got 60, 20 and 2. So 60 times 20 times 2 is 24,000 metres cubed, and because of our little conversion of units, that's 2.4 million litres. Just want to ask you to think about that for a second. 2.4 million litres. When you drink some water, so I've got some water here, I've been keeping myself refreshed with this during the morning. This is 75 centilitres, so it's about 750 millilitres, which is nearly a litre. It's about 3.2 million of these. 3.2 million of these. It's a lot of drink. I don't know how many people are going to try and... Obviously, that's why we don't try and drink the water in the swimming pool anyway. But hopefully, that's quite eye-opening to you. These are the exact answers. The length is 50 metres, the width is 25 metres, and the depth is 2 metres. 2.5 million is quite similar to 2.4 million, and we only used heights of adults. Therefore, you can see that using the heights of adults can get you a very close estimation. Now we're going to look at having a barbecue. I know we can't have social groupings at the moment. I know we're having to do this social distancing, and that's frustrating for everyone. I've read some stories of people who have been having barbecues and having to have the police break them up, which is a shame. But let's imagine that we're preparing a barbecue at our own home. I think for my barbecue, I'm going to want some sausages for £2.50. Okay, so we're going to add those to the basket. You might want to write this down as we go along. So I'm going to give you a second to write that down. Feel free to pause the video at any point if you're struggling to keep up. We've got 3.99, 2 packs of that. These are lovely burgers. They look like they've got some spinach or some greens in the burger, making them very appetizing. I tell you what, I'm ready for lunch now anyway, so this is quite difficult to go through. £5.30 for some beautiful vegetable burgers. I've started eating a few vegetable burgers recently. Eating a bit some vegetarian meals. I even had a few vegan meals. Very tasty. £3.75 for some chicken breasts. Obviously, if you are vegetarian, you don't have to eat them. These are just because it's for the whole family. Some bread rolls for £3.14. Some Coke. Obviously, not just one Coke, but enough Coke for different people. £6.99. Other colas are available. £4. Not everyone wants fizzy, so we've got some orange juice, some freshly squeezed orange juice from the looks of things. £5.14 for different salad, but they've got some croutons in there, cucumber, carrots, tomatoes. And then obviously Grandma won't come unless we've got a football. She wants to be in the garden kicking that football around, and so we have to buy a brand new football because unfortunately I kicked my one over the fence right at the start of the time we were at home. I was trying to do keep-ups. I managed to break my record of 4, so I've managed to now do 5, but then I lost the ball over the fence. So we're going to need to buy a new ball so Grandma will turn up for football. Otherwise, she's not going to turn up at all. So we've got £50. Have I got enough for all the barbecue? Feel free again, pause. Or we use estimating. Here's the estimated price, I think. we've turned all those numbers that I listed. You see the bracket is 4 times 2. That's because there were 2 packets of the £3.99. We add all of that together and we get £47. So it looks like we probably have, and there's a window of £3 either side that will probably save us. So we probably have got £50. If we were going around the supermarket, we would probably be okay. The real price, you can see, actually gives you £46.30. So it's an overestimate by very little. That, all those different barbecue products, and we still aren't overestimating by all that much. Now the final thing is checking your answers. I have noticed when I mark students' work, especially when they've done a test, there's a lot of them who, when they get to about halfway through a test, their facial expression and their body position looks a little like this. And they're fast asleep, or I've done everything I can. Sir, I can't do any more, it's too hard. Now obviously, that might be the case. But estimation is very, very good for checking. It's very good to allow you to check your answers. If you have had to do a complicated multiplication, for example 7.2 times by, we had to do the proper answer, 7.2 times by 255. So what I could do at the end of the test, I've got 5 minutes left, or maybe more if I've rushed through it. I'm going to turn that into 7 and that one into 300. That makes the answer 2,100. So I know my answer needs to be around 2,100 to be right. I won't know if I'm exactly right, but this is a good way of checking your answer. Okay? Now, you will have noticed my one thing. I did borrow this meme from an American site, and it makes me a little bit cringe that it says math, not maths. But never mind. I hope you are still listening and enjoying. I have some final questions. You can pause the video and try. This uses all the things we've done today. We've got a red one, an orange one, and a green one. Pause the video if you're watching afterwards, or if you're doing it live. Feel free to try and get some of these worked out. Okay? Now, if there are any questions you have for me, please do put them in the comments. What I'm going to try and do at the end of the stream is leave it open for a few minutes, answering any questions I see. Because I do want to be able to give people the chance to ask questions live if there's anything they weren't clear on, anything they're stuck on. But for those people who are doing these questions, I'm going to briefly put the answers up so they can check their answers, go back. Obviously, you can pause it on the answers, you can pause it without the answers. So give you a chance to do those questions and check whether you've understood everything we do today. Thank you very much. It's been half an hour of me talking to an empty room again. I'm trying my best to give you any help I can. I've done it a different way, and it spectacularly failed today, which is very frustrating. But we will try and get that sorted so that tomorrow it works even better. Sorry for the technical difficulties at the start. I'm 3 days into being like a TV channel, and these TV channels have been going for years. So I'm still learning the ropes. Do let me know of anything, and any live chat questions, I'll leave this screen on, and I will try and hopefully ask you for some feedback. So thank you very much, and if you've got any questions, use the live chat or put them in the comments below. Go to the Facebook page and request any topics. I'm hoping to do some algebra stuff, all sorts of different topics. If you ask me for them, I'll do them. Thank you very much. Take care.